Awesome. Did not mean to say that. So I think I'm the oddball talk of the conference because I'm not talking about frameworks. I'm talking about AI. Why? Because it's cool. And also because, while you're trying to figure out how you're going to replace your jQuery applications with Angular or Vue or React or Svelte, AI is trying to figure out how to replace you. Right? I'm going to show you, it's not too far from the truth, to believe it or not. I'm going to show you by the end of it what I think to be the first glimmer in the distance of an AI or a type of AI system that you might be working either very closely with or for. So thank you for the introduction. My name is Asim Hussain. I have a very, very short amount of time to do this presentation, so I'm going to be very, very fast all the way through it. Asim Hussain, Jawache, not Jawashe, is my Twitter handle. I blog about Angular and just Angular, I think, actually, and JavaScript on my website, codecraft.tv, and I'm what's called a cloud developer advocate at Microsoft. And that means I'm a conduit, really, between the developers, such as yourselves, and the product teams inside Microsoft. So it's a two-way street with us. If you've got any feedback on Azure, come feed it back to me, and it goes straight back into the product teams. So this is me. My journey this last year, web development, Asim, and machine learning. This is actually not my slide. This is my friend Eleanor's slide. So me and Eleanor go back a long way. And we were going on a hike, I think, earlier on this year. And during the hike, we're having some lunch, and we thought, a lot of very interesting things have been happening in 2018 with AI and machine learning and JavaScript. And we said, what we need to do is we need to have a meetup. We need to have something to kind of get people together to talk about this. And that's what we created. We created it in London. It's called the AI JavaScript Meetup Group. We've only been running for about 6 months now, but it's growing really, really fast. I'm really quite proud of it, to be honest with you. And one of the things that happened when we were running this meetup is people would start sending us demos, kind of JavaScript-powered, web-powered AI demos. Say, this is a really cool thing that somebody's built. And we thought, what we need is a place on the internet where we can collect all these little cool demos together and just show people what amazing things you can do on the web with AI these days. And that's what we created. It's called AI.js Rocks. You can go visit it right now. It's got a whole bunch of demos on it, and it's all written in JavaScript. So one of the criteria for being something that's on AI.js Rocks is it needs to be able to click it and play with it in the browser. And the other thing that we do with AI.js Rocks is for each demo, we at least show the source code, so you can have a link to see how it's working, but usually also a little bit more information about the demo, how it was created, so you can learn a little bit more as well. I'm also starting to interview a number of the authors themselves and placing those videos on the website as well. So it's a great learning resource. So what we're going to talk about today is I'm going to go through AI and talk about AI and the latest things that are happening with AI and JavaScript by going through 3 of the demos that we have on AI.js Rocks. One of them I built, 2 of them built by other people. So jumping straight ahead, the mojifire. It's not trademarked. It's just, the mojifire. So I thought it made sense. So the mojifire. So this is a project that I created earlier on in this year. And I think it's going to change everything. Okay, so what the mojifire does is it takes a picture of you and... Any guesses? Any guesses? Shout it out. Turns you into an emoji. Close. What it does is it figures out, because you can have multiple people in the picture, figures out where all their faces are in the picture, figures out the emotion that the person is displaying on their face, finds an emoji that accurately depicts that emotion and replaces it on the face. Okay? That's the mojifire. World-altering technology from awesome. So I released it earlier on this year. I released it as a Twitter bot. But before you get really excited and go on Twitter and start using it, so basically, listen, if you're using it, please don't do this right now. If you just take anything you found on Twitter reply with hashtag mojifire, and then it would do this. But unfortunately, because of perhaps some activities of perhaps some countries, perhaps on Twitter with perhaps some fake bots, Twitter has come down hard on Twitter bots, and I've been shadow banned twice now. Does anybody know what a shadow ban is? No. Shadow ban, a couple of nods there. The most anxiety-creating kind of ban you can get. You basically get banned by Twitter, but they don't tell you, and you can continue to do everything that you want on Twitter. So you post, still works. Everything's working. It's just no one's liking your posts anymore. It's a shadow ban, right? And also you can imagine being incredibly difficult as a developer to try and debug that problem, right? No one's told me. I'm basically guessed I'm shadow banned. But anyway, I keep getting shadow banned, so I've kind of re-released as a Slack bot. I'm going to show you some links so you can try and use that later on. But anyway, let's talk about the most interesting part of that, I think, which is how do you calculate emotion, right? I think part of that application, the most interesting part of it, is how can you calculate emotion? And it's incredibly simple. It's incredibly simple. It's just got 2 steps to it, okay? The first step is you need to figure out kind of the facial landmarks on a face, okay? There's a bunch of different libraries you can use right now, which can give it an image of a face, use well-known algorithms to find the different landmarks of the face. Each face has a distinct set of landmarks, okay? And the second step is just use an artificial neural network. Okay? And that's it. Just those 2 steps, and you're good. You're good to go. All right? Oh, do you want me to go into neural networks a little bit? I suppose. All right, whatever. So a neural network is actually got a basis in biology, something called biological neuron. So this is something you have in your brain, hopefully, a couple of these at least, and it's called a neuron. It has dendrites, a body, and axons. So in dendrites, if enough electricity flows into these input things, and the body decides it wants to pump something out, it pumps something out on an axon, and it goes out the other direction. If you stick kind of, I can't remember the exact number, I'm going to say billions of these together, you get a human brain, okay, that can do interesting things. But if you're looking at this, if you can imagine, you can actually convert this into code, right? It's not too complex. If you think about it, it's just a node and some edges going into the node. So you can imagine coding this up pretty easily in whatever programming language you want to do. So this is what you do. That's what you do. You create an artificial neural network. This is one basic neuron in that neural network. And that's what you do. It's just a node with some edges going into it. You pump some values in. I don't know what these are. Maybe number of McDonald's in an area, house price increase over the last month. There's actually a report in London that does coffee shops versus McDonald's and house price increases and decreases. But anyway, and that's what you basically do. You pump some values in. Each of the edges has a weight. You initially, with a neural network, you randomize these numbers. You pump it through something called an activation function. And basically, if the activation function just pumps a number out the other side. And that's all you're doing. You're just connecting tons of these together, and you've got an artificial neural network. So just to understand a little bit more about how it works, I'm going to do some animations. Pay attention. Boom. That's it. Right? All you're doing is multiplying things together. A way I always use to describe kind of machine learning and with neural networks is imagine you're programming and the only thing you could use is multiply. No ifs, all you can use is multiply. That's how you could think of a neural network. And this is all you're doing. You're taking those input values and multiplying them by the weights. You're adding them together. It's coming up with 7.01. It's passing it through an activation function. Whatever number that spits out, it can be whatever you want. Whatever number that spits out gets connected to the next neural network. There's a bunch of different activation functions out there. This is the one that this one was using. It's just a very, very simple one. Anything below 0 is 0. Anything above 0 is 1. But you can imagine here, it gets a little bit complicated. So it gets a little bit sensitive to small changes. So there actually are a number of other activation functions you can use. But that's beyond the scope of this, because what you basically do to create a neural network, ooh, that's an interesting animation. What you do is you basically get a number of these together, and you combine them into a neural network. On my monitor, these are purple, and those are blue. But anyway, so you have like an input layer, some hidden layers, and an output layer. This is a neural network. This is all it is. what you do is you then basically, initialize all the edges with some weights, randomized to begin with. And then you pump some values in. Maybe what this is all the different locations of facial landmarks on a face. Okay? Just imagine it. That's what you're inputting in to your neural network. And all it's doing is then multiplying those numbers together by those weights and outputting a number. That's it. That's all a neural network is doing. Lots of matrix multiplication. Maybe we're trying to train this neural network so 0 means unhappy and 10 means happy. So I pumped in some of my facial landmarks. It came out with 3. It thinks I'm unhappy. I know that's wrong. I know actually I am happy. Okay? So I know I should really be scoring 8. So I know that this neural network is off by 5. This is the magic of machine learning. How do we change these little weights so that the next time I pass these numbers in, it gets all multiplied correctly and it gives me 8? That's what you're doing. That's the training that's happening. And that process is called backpropagation. That process is called backpropagation, right? So we know we're off by 5. So it knows it needs to adjust these weights just a little bit so we get closer to 8 next time. And that's what you do. All you're doing is you're adjusting those weights to get closer to 8. And then when you pump in those facial, if you do this enough times, those weights get trained so it gets pretty accurate. So then when you pump in those facial features, it's going to pump out 8, which means it's pretty happy, right? That's a neural network. That's how it's working. It's just lots of multiplications and this magical thing called backpropagation, which is actually quite complicated. But it doesn't matter. There's always libraries that do it for you, right? And that's what you basically do. Now, at the end of the day, what you end up with is just a bunch of nodes and a bunch of edges. You can export this stuff. You can export it and save it as a JSON file or other formats. And then you kind of maybe import that into your own application. Then you can use it. You don't have to train it. You can just use it. Training requires tons of compute. Using is super easy. It doesn't require a lot of compute at all, right? And oftentimes what people do is they train them, they take the models, they put them on a server somewhere, they wrap it in API, and they charge you for it. And that's what we do as well. So Azure does. So a lot of companies do this as well. Amazon does it, Google does it, everybody does it. We have a lot of different services out there. We've got one called Cognitive Services. And the mojifire, that's what I use. I always think this image, Simone, it's so unfortunate. If you go to the Cognitive Services, does not look like somebody who understands. It's like, what's going on right now? I don't think that's the picture that we should be having here. Put an emoji on it. Not a bad idea. But yeah, it's a face API. It does a whole lot more than just detecting emotion. But to use it, all you have to do is basically make a post request, pass in a URL. You can actually pass in the binary data itself, and returns you an array of the faces in order to put an emoji on an image. Remember, that's what we're doing here, putting an emoji on an image. I need to know where the faces are. And it also returns an array of anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. 2 interesting facts. If you have a beard, according to the Azure Face API, you can never be 100% happy. And Simona's profile photo on Twitter is 100% happy. Just to let you know that. So just to summarize, I just wanted to get across here. Neural networks are just incredibly powerful. They're the things that kind of really driven a large amount of the progress in the field of machine learning in the past couple of years, right? But the other thing I really want to get across is conceptually they're really simple to understand, right? I kind of explained a really basic kind of feed-forward neural network in about 5-10 minutes, right? There's still a lot more to learn, but the basics are easy to understand. Oh, I'm slow. Okay, moving forward fast. TensorFlow, MobileNet, and I'm fine. What does my t-shirt say? Puppies, Azure, and I'm fine. It's a long story. The t-shirt says that. Just live with it. I gave a workshop a month or 2 ago when I was wearing this t-shirt and I was teaching people to do AI, to do machine learning in the browser. And then one of the attendees, Oliver Turner, then went away and created a demo of an app called TensorFlow, MobileNet, and I'm fine. I'm just explaining the title. That's why the title is called the title. Okay, this is the demo. So it's just a simple code pen. So what you can do is this does a search for Unsplash. This is searching Unsplash for puppies, getting an image from puppies, and then it's figuring out what's in the image. So for you, this is not a fair code, but anyway, it's okay. No, there's no sunglasses. Here, how about this? So platypus, duck-billed, platypus, paddle boat. Okay, so it's not very, very good, okay? It's okay. What about this one? Fountain, maybe, I don't know. Bubbles. Oh, it got terrier. Not too bad. What's the last one? T-shirt, sweatshirt, lab coat. Okay, whatever. So it's okay. It's not that bad. Now, the key thing I want to tell you about this demo right now, it's not making any API requests. In fact, no, it is making an API request. It's making an API request to Unsplash. The detection of what's going on in the image, what the image contains, that's all happening inside JavaScript, inside the browser. Okay? And it's using a thing called MobileNet, which we'll get into in a second. But the underlying technology that it's using is called TensorFlow. Has anybody heard of TensorFlow before? Anybody used TensorFlow? Okay, couple. Excellent. So TensorFlow is, it's like the machine learning technology, kind of open sourced a couple of years by Google. And I won't go into it in too much detail, but it is kind of the machine learning toolkit for doing a lot of machine learning stuff, and especially neural networks. It allows you to do lots of complex mathematical matrix multiplications across a GPU and across multiple nodes to really help you scale out your calculations, okay? But then about 6 months ago, they released, the animation hasn't happened yet. Wait. There you go. TensorFlow JS. Okay? TensorFlow JS. Now, the important thing to know about TensorFlow JS, and I think this is, when TensorFlow JS first came out, because TensorFlow is written in C, it's really hardcore optimized for doing, it's really optimized really for doing lots of mathematical calculations in C, right? I thought TensorFlow JS, when it was first released, I thought it was just bindings to the TensorFlow application that you installed on your computer, right? It's not. It's a complete rewrite of TensorFlow inside JavaScript. With JavaScript, not inside JavaScript. With JavaScript. Why is that important? It's important because of this. It means that the only thing you need to do to use TensorFlow in your JavaScript applications is just import one statement. There are no other dependencies. Well, that's probably what you would do if you're a proper developer. If you're a developer like me, we use script tags, still love script tags, my favorites. You use script tags, that's the most important thing. You can just drop a script tag in and start doing machine learning in the browser. That's incredible, right? There's a couple of different things you can do with TensorFlow JS. You can train models. So that thing I showed you before, where I showed you the neural network and how you can initialize them with weights and how you use back propagation to tune those weights. You can do that with TensorFlow JS in the browser. You can do that, okay? But the really interesting part of it, for me, I think, is that you can load pre-trained models, right? You can load pre-trained models. So you can take a model that someone else has built using Python TensorFlow, using thousands of servers, computed in the cloud, save it to a JSON file, and then load it inside your JavaScript application and use it, okay? And that's actually what was used in this demo. Used something called MobileNet, which is available in the TensorFlow TFJS models. You can find there's not that many. There's a couple of pre-ready-made models that you can use. But in order to use this, all you've got to do is import MobileNet, and it's going to mobile that node. It's going to do TensorFlow. It's loading a JSON file, kind of pre-trained neural network, which has been trained to detect 1,000 different things in the world. Okay, that's all it's been trained on, 1,000 different things in the world. And then all you have to do is you basically pass it the image, and it gives you back an array of predictions. And that's what you were seeing below there when you saw a duck-billed platypus with a percentage next to it. It was just, it guessed it was a duck-billed platypus, right? So it's pretty good. You actually tend not to use MobileNet in order to actually detect what's in an image. Use it for something else called transfer learning, which I do not have time to go into, but it's perhaps some of the most interesting stuff happening in the field of AI, and it's very, very relevant to us as JavaScript developers. But But yeah, it's just one of the way the guy used it. It's good. It's optimized to run in the browser. It's not very accurate. So if you wanted to get something a little bit more accurate, you would use... No. You would use maybe another API. There's lots of different APIs out there. We've got the Azure API here. There she is again. I have to get this changed. And then you could basically use it for a bunch of different, you basically pass it an image and it'll tell you what's in the image. And it does a lot of other stuff as well. In fact, my colleague Sarah Drasner created a little demo recently, and not recently, a couple of months ago, which used the API, does some really interesting effects. So try to do for accessibility. Wouldn't it be cool if you could take an image, pass it through the API, figure out what's in the image, and use that as the alt text, okay, which screen readers would read out, okay? Pretty interesting idea. So this is an image, this is her demo. This is an image that it's created. And in fact, if you look at what it actually created, it actually creates a caption, not percentages, but an actual caption to describe the image. So a black and white photo of Thomas Edison. The text says, hey girl, did we just share electrons because I'm feeling a covalent bond between, I don't know this stuff, what it means. The interesting thing I want you to know is the two things. A, it knew it was Thomas Edison, not just a man, but Thomas Edison. And it read the text from the image, right? So it can do a lot of really, really powerful stuff. Just like everything in life, though, it doesn't quite work out all the time. When she posted on Twitter, a few people kindly replied with a few examples it didn't work with. This is one of them. So it says, a star-filled sky. The text says, I don't know what that is. I think it's some Asian writing there. The next one, I think, I don't know, could be true. Could be true. I mean, there might be stuff, like you don't know, right? I mean, I hope they're not stuffed, but there might be stuffed animals. And I like the last one because I think we're half right here. Okay? We're half right. So it's pretty, so it's not, even we can't do it right, but we can do it pretty well, okay? How long have I got? Ooh, just enough time. Maybe not, I don't know. Summary. Okay, so this is the most important takeaway I want you to take away from this. Okay, this is it. From the whole talk today, this is the only important takeaway I want you to take away from this. TensorFlow.js doesn't have any dependencies, right? You can do it just by dropping a script tag on a page, and you can start doing machine learning in the browser. That's incredibly powerful, right? Just MobileNet is a really simple way to kind of analyze images. I use it in my workshop that I do, and it's just a really quick and easy way to give people some powerful functionality, right? But you don't really use it for that. If you really want to figure out what's in an image, you want to use an API. There's lots of different APIs out there. Obviously, there's a really good one out there you should probably take a look at. All right. My favorite demo by far is this one, okay? Image to image. Created by a student. I was not doing good stuff at university, trust me. A student called Ziad. He's actually studying he's Yemenis, studying in Saudi Arabia. I interviewed him. His video is going to appear on AIJS Rocks shortly. A very, very clever little gentleman. Little gentleman. And this is his demo. And I'll just show you what it does. So it draws pictures of cats based off of the outline of a cat. Okay? That's using a technique from a paper called Pix to Pix. Now, this is all running in the browser. This is running in the browser. If you go to AIJS Rocks, you can do this. It's running in the browser. There's lots of other different demos on there as well, but this is one that's running in the browser. Now, it's using a technique called Pix to Pix. And it's using neural network underneath, and again, it's using TensorFlow.js, and it's using something called a generative adversarial neural network. The technique has only been understood or been released about 2 years now. And I think it's one of the most interesting things that's happening inside AI, and also probably the scariest thing for everyone of you in the audience. Okay? So how it works is this. I'm going to really try and explain how it works in 4 minutes. Let's see. So it actually works by having two neural networks that compete with each other. They're competing with each other. Okay? So you've got one neural network here. It's called a generator. One there is called a discriminator. The generator's job is to create images of cats. The discriminator's job is to figure out if an image is a generated image or a real image of a cat. Okay, that's all the discriminator has to do. So what happens is you feed in a sketch of a cat, just a sketch. Maybe you're just feeding them, maybe each pixel value gets fed in as one neuron, as an input. The whole thing, remember, is being randomized as random weights. It's not really going to do a really good job of generating a cat. It's probably just going to create like some white noise to begin with, right? That's what it's probably going to create to begin with. You pass in all the sketches, you get all the generated white noise images, and then you get all of them and you get all the real pictures of cats, you feed them into the discriminator. And again, the discriminator is just being randomized weights to begin with, right? So it's probably not going to do a really great job of figuring out if it's a real cat image or a fake cat image, right? So maybe it gets it wrong first time round. If it gets it wrong, it does that thing called backpropagation, right? You're tuning those weights so that next time round, it does it a little bit better. And then maybe it gets a little bit better at it and it detects it right that time round, but it detects it knows that the generator did a bad job. So the generator gets backpropagated and it gets tweaked to become better. Then over time what happens is that they're both just getting better. The generator's getting better at generating cat images. The discriminator's getting better at generating, distinguishing between cat images. And they're both learning together and they're both improving over time, okay? Until eventually, the generator is producing such good cat images that the discriminator can't tell and then the generator's done, okay? This whole process requires a lot of compute. You don't really run this in the browser or anything like that. But the generator model, once it's been created, once it's been trained, you can export that as JSON and run that in the browser as TensorFlow.js. And that's what Ziad was doing, right? And so once it's trained, what you can do is you can add in your own sketches and it's then going to try and generate its own cat image, okay? That's how it's working, okay? It's all funny, right? Because it's all just pictures of cats. But what is this technology for? Like, where is it going towards? Here's perhaps something that isn't so funny. Okay, this is another model called vid2vid. This doesn't run in the browser yet. Vid2vid. Okay, so this image here is generated from this image here. Okay, pretty accurate, right? Gets more interesting. How about this one? So, okay, she's not dancing. Okay, this is generated from some images of her that it trained on, and then you can pass in new ones of this, and it'll generate new dance moves, right? This is generated. There's this one, which is really interesting. So you can do it again not just by sketches, but by segmenting of images. So that's the input. This is vid to vid. That's pix to pix. Vid to vid output. It's pretty close, right? Pretty good. If you're actually very, very close to this, you can tell a little bit of weirdness. There's like a blob exiting a car without any legs. And there's a couple of weird things happening there right now, but it's pretty close. But what I think is perhaps one of the most interesting parts of this is you don't have to pass in images, right? When the generator before, we're passing in sketches of cats. You can pass in text that describes a cat. And that's what this has been trained on. This is StatGAN. So it's been trained on text. So these images here have been generated with only the input is this text at the top. So this bird is white, black, and brown in color with a brown beak. This is after 600 epochs. This is after 1200 generations, after 1200 generations. Pretty good, right? I think there's one bird here that's kind of weird, this one. But the rest of it's pretty good. And the top one is similar, but for flowers. Okay. This is where it's going to get a little bit interesting. How far away do you think we are from building something where you can say, create me a form with 4 input fields. One of them should be a date field. It should only accept dates from 1999 onwards, and a color field. How far away do you think we are from that? Because I don't think we're that far away, to be honest with you. So to summarize, GANs are a great way to kind of, they learn, they're called generative. So they generate new bits of information. They generate new images or perhaps new forms. But they take a lot of compute to train. In fact, they actually take more compute than a typical neural network to train because they're doing a lot more. But you can create, once they're trained, you can actually create a generator model that can be run in the browser. They're still pretty big. Ziad managed to get the Cat 1 down to 13 megabytes. Still pretty big to load in the browser, but small enough now, all right? And just kind of some final thoughts I have on generally the subject. Oh my God, I'm sorry over time. No final thoughts. What I'm going to recommend to you is if you want to learn a little bit more, if you want to learn how to build the mojifire, I have just released it as a Slack bot, and I'll show you how to everything from the ground up, how to build it and how to create a Slack bot. Right now, it's not going to point to the Slack bot version. It should hopefully be released tonight. And then the link should take you to the right place. But maybe for the video people, you'll have the right link. So thank you very much for your time. Bye.